Section 10 deals with change, and we're expressing the change as a percent. So right off the bat, we have some vocabulary we have to talk about. Percent change, percent increase, and percent decrease. If you know what percent change is, then percent increase and percent decrease kind of comes along pretty easily after that. Percent change is how much an amount changes, and we're going to be talking about that as a percent. So if that's percent change, then percent increase is going to be how much did something grow. And we're going to be talking about that as a percent. Percent decrease would be how much did something shrink or get less or go down. And again, that's going to be as a percent. So there's a formula that we're going to be using. The percent change formula that we have is sitting right here. From the original number to the new increased or decreased number, actually in this case the new increased number or price or whatever it is that you're dealing with, will be percent change equals the new number minus the original number divided by the original number. This is something you got to kind of memorize. All right, the other formula that we have is the percent decrease. It's very, very similar to the percent increase one, and it's easy to get them confused, so I'm going to hopefully try to show you how to not confuse them. This formula is your percent change if you're talking about a decrease, like if something goes on sale, somebody becomes shorter, like my grandma, as she becomes older, she gets shorter. We could be talking about her percent decrease of height. Okay? New now is at the end. On the other one, it was new first minus original. But now, since we're talking about decrease, they switch places. We have original minus new, but we're still dividing by the original. So both formulas have divide by the original. It's just a matter of which one goes first on top. So here's the key on how to keep these straight. If you mess either equation up, meaning if you, instead of, like you have a decrease, but you somehow forget to use the decrease formula, and instead you write new minus original, what's going to happen is you'll get a negative sign in your answer. If you get a negative result, all that means is you used the wrong formula. So you probably just didn't know this, whether it was an increase or a decrease first. So the first thing you want to do on these problems is decide, is this an increase or a decrease? If it's an increase, you'll use the other one. If it's a decrease, you'll use this one. If you mess up and you get a negative result, you just use the wrong formula. The ending number will be the same. Okay? So your answers will always be positive here. You'll just have to also say, is it an increase or a decrease? So for example, a coat's on sale. The original price was $82. The sale price, $74.50. I should have a dollar sign sitting there. What is the discount expressed as a percent of change? So first of all, we need to say, okay, is this an increase or a decrease? It's a decrease, right? Because we started at 82 and we wound up at 74.50. So the price got lower. That means we decreased. Okay? So we're going to use the percent decrease formula, which is original minus new divided by the original. By original, I mean the original price minus the new price divided by the original price. So we're going to write P percent equals, that just represents percent change, the original price, which was what? 82, minus the new price, which is 74.50, divided by what? The original price again, which is 82. So you are going to need to use a calculator here, because again we're using percents and you're going to want decimals, and you're not going to want to sit there and spend all day trying to figure out what the decimal is going to be. So first you do 82 minus 74.50. and then press enter, and then divide by 82. Or on your calculator, set up the fraction template, a little dotted box over a little dotted box, so that you make sure that you have it right. Or you could just type in parentheses, 82 minus 74.5, close the parentheses, and then divide by 82. All three of those ways will get you to the answer. Whichever way you chose, what did we get? 0.0914? Okay, so I'm just going to round there. Now that's a decimal, but we want percent, so what do? Multiply by 100. So we wind up with 9.14. I'm rounding, so don't forget your percent symbol. 9.14%. So that'd be 9.15. Yeah, thanks. Since it was 9.146. Okay, next problem. We have a store selling a guitar for $295. Apparently it's a pretty popular guitar, so they figure they can make some more money off you when you go in to buy your guitar, and they mark the price up to $340. What is the markup expressed as a percent of change? This is an increase. Yeah, we started at $295, and now we're at $340. They jacked the price up on us. So hopefully you got there before they did that, right? All right, so we need to figure out what kind of... By the way, let me go back real quick. Sorry. This is a percent what? Increase or decrease? Decrease. So we need to say that. This is a decrease. So, sorry, I just forgot that. On this one, this is going to be an increase, we said, so I can answer that right away. And it does help to do that because that helps write down which equation you're supposed to use. So we'll have P percent equals what? Are we doing new minus original or original minus new? This is an increase, so this is new minus original over the original. So that's going to be P percent equals 340 minus 295 over what? 295, the original. It's always over the original. And then in the end, we're going to have to multiply that times 100 to get our answer. So this becomes P equals, that's like 45 divided by 295. What do you get? And you multiply by 100 already? Okay. 15.3. Rounding to the nearest tenth is fine. So 15.3% increase. Don't forget your increase here. Next problem, in 1 year, the price a troll charged for innocent people to use this bridge rose from $3 to $3.50. Times are tough for the troll. He has to make more money. What is this percent change? Go ahead and try that one on your own. So are we dealing with a greedy troll here or a nice troll? I think it's nice. $3.50 is a reasonable price to cross that bridge? Could be. Maybe it's a really nice bridge. Or maybe he's doing some maintenance on it. He needs to make more money to pay for the extra boards, right? But either way, is this an increase or a decrease? This is an increase, so I'm going to write that down. And then I'm going to write P equals what? $3.50 minus $3 divided by $3. The original price, right? Okay, so $3.50 minus 3 is 50 cents divided by 3. Multiply by 100 and you get 16.6 repeating, so 0.67. I don't want to need a repeating there, percent. So I want to tell you guys a little trick. I did. Increase. I want to tell you guys a little trick. Both of these formulas deal with the bigger number minus the smaller number, divided by the original number. So if you can decide if this is going to be an increase or a decrease, then all you have to do is always put the bigger number minus the smaller number, then divide by whatever the original number was. Okay? What that does is it straightens out any issues that you might have with negative signs or anything like that. Okay? Can you remember it that way? All right. I think that's the easiest way to remember it. Okay, we have average monthly rainfall in Chicago in June is 4.1 inches. That's kind of funny because the average yearly rainfall in our area is like 6 inches. So in 1 month, Chicago gets almost as much as we get all year long. In December, it's 2.8. What is the percent change in rainfall from June to December? So if we're going from June to December, this will be a percent increase or decrease? This is a decrease. And then P equals, so I got to write this down first. The big number, 4.1, minus the little number, 2.8, divided by the original, which is what? The 4.1. Okay? And we multiply that result by 100, and what do we get? 31.70, so 0.7 is good enough percent. Okay, you can now do 7 through 17 all, so go for it. The last thing we're going to talk about in this section, and also the last thing we're going to talk about in this chapter, is something called error. In your science classes, you may have talked about error before, like human error. Well, when you talk about error, there's two things you can talk about, relative error and percent error. Usually we talk about percent error, and that's going to be what we're focusing on in this section. But you need to know what relative error is in order to calculate what percent error is. If you look in this formula down here, relative error is the absolute value, which is what those guys are right there, those two bars, absolute value of the value you got by estimating or measuring or whatever you got, minus what it was supposed to be in the first place, divided by what it was supposed to be in the first place. So like if the football field is 100 yards long, and I measure it and I get 94 yards, I'm wrong, aren't I? Yeah, because it's 100 yards long. So this would be the 94 that I got, minus the 100 that it was supposed to be. I'll get -6 if I do that. But the absolute value things here tell me to just make it positive. Whatever answer I get in the numerator, make it positive. Then divide it by the actual value, 100 yards. Okay? So relative error is the ratio of how wrong you are, basically. And the percent error is just that ratio as a percent. So it's just how far off as a percent you are. It's very easy to calculate both of these. To make your answer the percent, just multiply by 100. So you're going to actually divide this out. So in my problem, I got 94 yards out of 100 yards in the football field. So 94 minus 100 would have been -6. But I absolute value that and make it +6. And now I have 6 divided by the actual value, which is 100. I get 0.06 when I do that. And then I multiply by 100 to get the percent. I'm off by 6%. Okay? That's the idea on these problems. Not that big a deal. Okay. You guessed that a rug is 5 feet by 8 feet. It is actually 4 feet by 8 feet. And then it says, what is the percent error in the estimated area of the rug? So my dimensions were 5 by 8. The actual dimensions are 4 by 8. And I need to figure out the percent error in the estimated area of the rug. So that means I need to calculate the areas. My area and the real area. What's the area of the rug according to me? 5 by 8. How do I calculate area? Length times width. So the area of this rug for me would be 40. What's the real area of the rug? 4 by 8. So that's the real dimensions of the rug. So therefore, what is the real area of the rug? 4 times 8 is 32. Okay, so now I can calculate the percent error. I take the measured or estimated value, that's my guess, which is 40. Then I subtract the actual value, which was 32. I need to make that an absolute value, which is no big deal. All it means is make it positive if I get a negative. Divide it by the actual value again, which was, what, 40 or 32? It's 32, the actual value, the real area of the rug. So 40 minus 32 is what? So 40 minus 32 is 8. That's already positive. So when I do this, I wind up with 8 over 32. Divide that out, and I get, so it's 1/4, but as a decimal, that's 0.25. And if I want that to be a percent, move the decimal 2 places over to the right, and I get 25%. So my estimate was off by 25%. Okay? That's all you do. None of your answers will be negative. If you get a negative, it's because you forgot to take the absolute value here. You're always going to wind up with a positive result. You could say 25% over because my number, my estimate, was over the actual, but 25% is the answer. So I'm going to write 25% over. That's probably a good idea to do. Okay? Okay, the next problem. You think that the distance between your house and your friend's house is 5.5 miles. But maybe we got on Google Earth and measured it, and it actually was 4.75 miles. What is the percent error in your estimation? So we need to set this problem up. What do we write? My guess, which was 5.5, minus the actual distance, which was 4.75, divided by the 4.75, which was the actual distance again. And I need to put that in absolute value just in case I wind up with a negative result. Then I'm going to multiply that times 100 to give me the percent. So the error equals what? So 15.789, so I can make that 15.8% off. And that was an overestimate or an underestimate? Over. So I'm going to write 15.8% over. And again, I don't think the book asks you to say if it's over or under, but it's not a bad idea to say over or under. All right, the last problem is a little twist on the same type of idea. A student's height is measured at 66 inches, but then they say to the nearest inch. So you're kind of estimating there. And I'm saying that I can measure your height within an inch either way. So if I tell you you're 66 inches tall, I could be off by an inch in either direction. Okay? What are the student's minimum and maximum possible heights then? If I say it's 66, but I could be wrong by either an inch over or an inch under the actual estimate. What's the lowest height the student could be? 65, correct? And 67. Nope, because it's plus or minus 1 inch. Okay? I tell you you're 66 inches tall, but then I say, you know, I could be off by an inch either way. So that means you could be 65 inches tall at least, or you could be at most 67 inches tall. You're somewhere in between those two. Okay? So when you see a problem that looks like that, what are the student's minimum and maximum possible heights or something of that nature? This is what you're doing. You're just trying to come up with the two ends of where that value could fall. And that's all there is. So that completes the section and the chapter.